Hello everybody, I will start my today's another live coding session. So today I have this question. Design add and search word Design add and search words data structure. Design a data structures that support adding new words and finding if a string matches any previously added string. Yeah, implements the word dictionary class. So for my expression is that I can just use the hash map. Yeah. So with the constructor, I initialize the object, and for addWord method, which takes a word, this adds word to the data structure. It can be matched later, so this should return nothing. For search method, I will return true if there is any string in the data structures that matches a word, or false otherwise. Quite intuitive. And word may contain dot, where dot can be matched with any letter. Okay, so this part is tricky. So let me clarify my understanding. So as the interface, I will implement the word dictionary class. And for initializer, it takes nothing and return nothing. It just initiates a new word dictionary class. And for addWord method, I'm given the string word and I return nothing, but this word should be registered. And for search method, again, I'm given the string word and I will try to match. Sorry, search a word. And this returns Boolean true if there is any string and false otherwise. Okay. Obviously, this is a side effect. I register word. Okay. Good. So let me check some constraint. So my biggest concern is word consists of which chars. So this is my concern. So definitely probably A to Z and dot, maybe for search word, but let me check. Wording addWord consists of lowercase English letters. It's A to D. Yeah. So added word is like this, and searched word is A to Z and period. Okay. So now it looks good. So I have to take care that this dot represent any of A to Z. Okay. A small thing I've noticed here is this is 026, which is a constant. So this means that creating, say, hash map for each char takes only the constant time. Or for loop for each char takes only the constant time. Okay, good. Okay, so let me take a look at examples. So I initiate something like predict in this way, and I say addWord like ABC. And if I search with ABC, this should return true. And if I search with, say, ABX, this should return false. So for OK. And when I search with, say, AB dot, it should return true, because dot represents a single, dot can be merged with any letter. But if I have a dot, I should return false, because dot is, matched with only single character. This doesn't merge with BC. Okay. So for good, I think I covered all the cases. I have to think. Okay, so let me think of the brute force approach. So obviously the brute force approach is store words in hash map. Yeah. Then search in hash map. Yeah. Sorry. Add and search a word in hash map. So for this, when I search, say a.x, I will try AAX, ABX, ACX, or AZX. I try each of these, strings, and if any of them matches, I return true. But nothing matches, yeah, which means that I return false. And let's say I have something like this. In this case, I try A B, A B, 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 A, B, blah, blah, blah. So I try each of A to Z for each dot in the search word. And if there is any word which is included in the hash map, I should return true. Otherwise, any of them are found, I return false. Okay. Good. So in this way, let's say L is the length of the word. And let's say there are n words added so far. In this case, for addWord method, it takes O of L, because what I have to do is register this word, which is length L, to the hash map. So basically, hash map takes only the constant time to add a, single element. But if there, word is a kind of tuple of the element. Tuple of the L element, so it takes O of L time. For search method, and with sulfur, and D is number of dot. In this case, it should be 26 to power of D. So there are this number of possible search word, converting dot to any of the character times. It takes, for each search word, it takes O of L time to find it in the hash map. Sorry, confirms the inclusion in the hash map. Yeah, so it should be like this. Good. And actually D can be up to L, so I can say this should be, yeah. Okay. So, but I think I have to speed up, maybe. Word ranks is up to 25. So it can be, at most 2 dot in the word, for search query word. Okay. So this is actually, L is 25, and D is actually up to 2. I think this is quite constant combinations. Yeah, but I can find 10 to the power 4 calls with made to addWord and search word. L is 25. So I think this could be acceptable. Yeah. But I think definitely the optimized solution is using the try. So let me try it. No pun intended. So let's say I add ABC. And I have, say, A.C. In this case, I start from A. And let's say D, D. Okay, let's say I have AAC, ABC, and AC, say, X. Yeah. Let me do this. So, okay, in this case, I start, I register AAX, ABX, ACC in the try because of the previous calls. And let's say I'm searching for A.C. In that case, AAX, when I come to AA, so let me have one more. So this is root. Okay. In this case, I start from root and I have A, so I go to this A node. Then I have the dot node. So I can be any of B, A or B or C. Then I have C. So when I come AA, then X doesn't match C. AB, X, this X doesn't match C. But when I'm here and I come down to, I notice that there's node, child node C, so this matches. Yeah. So basically what I can do is use the recursion, kind of. So it's not just going down to single path. If there is a dot, any, node in the same level, any sibling nodes are allowed, so I have to try each of them. In that sense, I can say it's a kind of recursion, or maybe I should say divide and conquer. Yeah. So that being said, I think this still, optimized. This is still optimized. Sorry, this does some optimization because let's say I have A at the first word. I come down to this A node. I don't have to check this middle anymore. However, in the hashmap approach, no matter which character is the first character in the search word, I try to see each word from the beginning. Yeah. So it never filters by the first match or second match. This is true when it's longer, like AAAX, and I'm looking for AAAA something. Yeah. So I can completely filter out this or this or something like that. But in the hashmap approach, I check in this. Yeah. So I think using a try optimizes my solution. So let me do the complex analysis. So for addWord method, yeah, it's still over time because I have to go down L steps from the root node. For search, in the worst case, yeah, each node has, I should say, yeah, worst case is that I have two dots at first. Yeah, obviously. So this is the worst case because I don't filter anything from the first two steps. So in this case, there's the first layer. Sorry, this one. First layer, I cannot skip. Second layer, I cannot skip. And from here, I will check every possible, combination. Sorry, path. This should be, and in the worst case, I start from this, and it should be, single pass from this. It should be like 26 to the power of d, and then after that, I go down. Yeah. Right? No, 22 things. From each, I go down to L minus d. This should be product. From each, third level node, I start the traversal of L minus d ranks. Yeah. So this should be the time complexity, which is because L is larger than d, we can say L times 26 to the power of d. Oh, this is quite smaller because, compared with L times 26 to the power of d. No, the same. Okay. So I think it doesn't work trying, so, try maybe. But for space complexity, definitely this should be smaller. The try should take less space. In the worst case, in the hash map, it takes L times n complexity. But for this can be space complexity is up to L. Oh no, Ln, but up to 26 to the power of L. Yeah. Basically, they're the same. Yeah. So let me go with hashmap method, hashmap approach. Okay. So sorry, I was always saying hashmap, but it's just a set. Yeah. Or maybe another approach is that when I add this ABC, I can add each of a.bc dot a.c and ab dot to the hashmap. Sorry, set. In this way, in the case there are so many search but small amount of register, I think this approach is good because in this approach, adding method takes L times L squared time, but for search, it takes only the O of L time. Yeah. But let me go with the simplest set approach. What should I do? So A, like, if word is A dot B dot, probably I will do the DFS or maybe backtracking to create each, No, it's been 20 minutes. Generate each string. Yeah. Okay, yeah. I think this works. That being said, implementation wise, this set to approach is better. So this is set version 1. Oh no, this is set version 2. This is set version 1. Okay, so I think this one looks easier to implement. So when I do the time compressed analysis, this addWord takes L squared time compressed T. Search word takes O of L time time compressed T. Oh no. This should be L squared times L because there are wait. No. I have to mask if I have ABC. Also, I have to mask something like this. Dot dot C. A dot dot. And yeah, something like this. A bit annoying. So LC2 is L squared. And I register each word, which takes over time compressed T. It should be L cubed. I think this isn't optimized at all. Maybe worst. Because L can be up to 25, but D can be up to 2. So L cubed is quite impactful. I don't want this way. Okay. Sorry. That being said, I come back to this first set approach. Yep. So I did the backtracking. I should do maybe self dot. Actually, I'm thinking if there are only 2 dot, I get first dot index and second dot index, and then I try for loop. I mean nested for loop. Like shy. This is pseudocode. Then yeah, something like this. Rather than doing the backtracking. So let me go with this. So I use this helper method. I iterate A to Z. This is old 1, old 2, and then char 1, char 2. Okay. So what I can do is this is a given, chars. So the first thing I can do is if first dot index is none, this means that as the interface, yeah, there's no dot. So I return, I check with this original word. Okay. Next, if second dot index is none, I should loop on the first one, but I can write it in this way. So here, for the first dot index, where is it? Chars. Is it char? Okay. Then here, if second dot index is none. Wait, I think this is quite confusing. What the heck am I doing? So let me come back again. Let's say this is a dot b dot. The possibility is that I have to think what I should put on this dot and also this dot. Yeah. I think in the end, I should use the backtracking, which is more simpler. Let me change this. So what I can do is I put the chairs list and basically this backtracking recursion method does the search. And prefix is decided, rare. So let's say I have, say, a dot b dot, then this is a start index. Here, if I is equal to ranks of the self dot chars, which means that all of them are met. I mean, filled in. So search word is like this. And I search it in the hash map. Sorry, hash set. Okay, this is it. Otherwise, I will check what the current char is, and if it is dot, I update it with any of A to Z and call the search with fixed prefix. with I+1 dot index. So let's say if I is not dot, sorry. So in this case, I just call search with fixed prefix I+1. Okay. The last case here, if the chairs I is A to Z, so the current char should like this. So I update chars with this. Then I do the recursion here. Good. Then I come back and I revert this to, wait. Yeah. So I'm expecting that this should be dot here. Okay. So I roll back this change I made. No. And wait a minute. I call it and roll it back. Yeah, and that's it. And what I can do is, if any of this is true, I return true. But I have to take care that if I do this, this self.chars I is not rolled back. Is it okay? Yes, I can say this is okay because, yeah. Once I find the true, it should come back to the root caller and true should be returned. Yep. So this is fine. Okay. So being said, I finished the implementation. So let me try it on my code. When I think of the test cases, yeah, definitely I should try with something which includes this dot, especially 2 dots, which is quite tricky. So I try with this. Okay, so firstly, I initiate the word dictionary and I add word ABCD. Then I search with A.C. and this expect true. Okay. So firstly, I initiated and words has a set. Good. And words that add word, which is ABCD. So this words dictionary, hash map, so hash set has only, ABCD. Okay. Oh, sorry. Let me speed up with just ABC and the A dot dot. Okay. So in this case, I call the search method with A dot dot. Self chars is now A dot dot. And I call this method from index 0. Oh, I didn't call it. Yep. So now I is 0. So I go to line 108. self.chars I is A, which is not dot, so I go to line 103. This is not dot, so this is true. I go to line 109, and I call self.search base prefix index I plus 1. So first I code with index 0, then I'm calling index 1. So now 1 is not chars ranks, which is 3. I go to 110, not dot. Sorry, this is dot, so I go to 113, and I check each char A to Z. Yeah. And let me speed up here. Or I should say, let me check only the happy case. Let's say old is now, char is now B. In that case, self.chars I is updated with B. So A dot dot is now looks like AB dot. Yep. Then I call the search with prefix with I plus 1, which is 2. Okay. And in index 2, the same thing happens. And I come back to line 118, and I try A to Z. Let's say I try C here. In that case, this becomes ABC. And I call another recursive function like this. Now it comes to line 113, and 3 is equal to 3. The search bird is created as ABC. Yep. And now self.birth, which is ABC only, includes ABC, so this should return true in line 115. So this returns true, yes, good. And because when true is returned in line 124, this becomes true, so true is returned. So this is true, so in the end this returns true, and this returns true. And when I come back to 0, in the 0 case, I was checking it here. So true is returned in 118, self dot something. Then now this returns true as it is. So in the end, line 109 receives true and returns it. Okay. So I confirm that this is true as expected. I can say I passed this test case. Okay. So now let me submit my code. Order. Okay. Say order. Yeah. Good, accepted. I will submit. Wrong answer. Oh. Okay. I should return false instead of null. So where is it? Okay, here. After checking this, I should return false because I couldn't find it in the end. Good, accepted. Okay, so let me quickly wrap up. So today I solved the question, design, add, and search bird data structure. Even though this question sounds really like the try question, I actually didn't go with it. I used the hashset. Okay, so with the hashset, I just add each bird into the bird hashset, internal hashset, and for search bird, if there is dot, I try each dot with any of A to Z, each of A to Z, and for every possible search word replaced, which is generated by replacing dot with A to Z, I looked at the hash set. And if there is, I return true. Okay, that being said, I finished my today's coding process. Thank you so much. Bye.